Welcome back, everyone. To start this off, what I want to do is, again, just really refocus your thinking about what machine learning is and try to imagine that machine learning is really just about prediction. And of course, that is a lot harder than it sounds. If we try now to take prediction, there's two things that we can actually do. We can look at this idea of regression. Okay, and some people, there's different versions of regression. It's the simple idea of two sort of axes drawing a line of best fit. Okay, but then there's this other idea of classification. And classification is, do we get an email, is it spam or is it real? And if it's classified as real, it goes to the inbox. If it's classified as spam, it goes into the spam folder. So classification is really something that I want to focus on in this particular video. And I'm hoping that we can look at an example of spam versus true valid email. Okay. And so when we look at linear classification, something that we end up having to do is actually, we've got to frame the problem. Okay. And the first real thing, the challenging part really, believe it or not, sometimes is to acquire and then organize that data. And then from there, we consider possible solutions. And from possible solutions, then we have to kind of characterize this objective. Okay, and then what we talked about this last time is that we apply an algorithm to the data that we have acquired and organized. And then we run this program. Okay, we've written all this and we're going to write this in Python, but we run this program. And then finally, we validate this solution. And so what happens is it creates these two major challenges that we need to solve. And the first one is estimation. The second one is this idea of generalization. Okay, so if we look at estimation, we need to organize data, which allows us to make an estimation so that our results are consistent in the future. Suppose I have this set of temperatures that I know that I have right now, and they're these 18.2, 19.5, 18.6, and I can create a statistical average of what those are. Okay, and then when I look at generalization, it is how do we make a sound prediction from a data set that has never had a predictable outcome? Okay, and you might say, well, the weatherman does that all the time, which is true, but how often do we totally put 100% faith behind our weatherman? So in this particular case, now we make a prediction about the temperature tomorrow. And so we have this scenario of what it is, what we know, and we're trying to make a prediction about what will be. So we have two very separate questions to answer, and we're using estimation with something called generalization to make this predict. And this is incredibly difficult to do, this idea of generalization, because how can we predict results of a situation or an experiment that we've never encountered before in the actual data set that we have? Okay, we don't have the answer in our estimation, but we're trying to use estimation to set the conditions for this generalization. And so this sets the conditions for this problem of induction. Okay, and why do we believe that the historical data can help predict the future? This is a challenge, not an easy thing to do. And so because of this, we make assumptions. Okay, and we make a lot of them. So if we look at this idea, this linear model as one of our examples, we are making assumptions that all training data are both independent and identically distributed, and that the queries will be drawn from the same distribution of the training data, or that the answers come from a set of possible answers that are already known to us. Okay? And stop there. So when we look at this, we can actually break this down into a set of problems and solutions. Really, if we were to look at just the problem class itself. And we broke down the problem class. We could get into this thing called we could talk about supervised learning. And I touched on this previously. And today, supervised learning, we can break it down into regression, like I said in the beginning, and then classification. We have unsupervised learning, reinforcement learning, even sequence learning. And so here we know that supervised learning, we have these relationships to the data and their eventual prediction. And if we look at big X or capital X, and we define that as being our input data. And then we have our output data, the prediction that we're trying to make, which is a Y. We've got this relationship here. And so what it's saying is we add X in, we process that with the computer, and then we output a prediction. We output a Y. And that's really essentially what we're trying to do with this supervised learning. And we're using data, a test set, as our input or our X in order to create the output, the prediction. So, as an example, we could say the inputs are a patient's vital signs, and the output might be the prediction of, are they having a heart attack? From a practical point of view, you can consider the inputs, the X's, as an actual vector, okay, in D dimensions. So we're going to say that the X input is a vector. But as we consider that the X is a vector, what we're going to try to do is consider that our Y is a maximum minimum value of a +1 or a -1. And this is really the heart of what makes it the classification, because it is one of two things. It is either a +1 or a -1, and therefore this makes it a classification problem. And this is really important to try to understand. We are classifying it into one of two possible groups. In this case, it's either +1 or it's a -1. And because of this, finally, this further breaks down into a binary. This is a binary classification problem. What are the X's? And really, what are they? And that's the thing. They could be songs. So X's could be songs or patients or information about the stock market or currency pairs or something like that. And so that really becomes a little bit of a challenge for us, because we need to characterize them somehow. How do I represent or characterize a song? How do I characterize a whole bunch of patients at a hospital? Okay, and that becomes a really difficult challenge sometimes. And so we have to come up with this idea of a feature representation. So our X's are these features that we're interested in. And so if we are to look at songs, and we have to do this, how do we convert these songs, into a feature? Well, that's the challenge, because that's actually our job. It is our job to go and convert that song into some sort of a feature that we can represent in a mathematical or a programmatical way. So as the machine learning practitioner or developer, a song is just a song, but we have some feature representation that can take a song and then give us a vector. And that is the thing that we have to design. So if you want to achieve some real world machine learning problem, then you have to do something to figure out how it is that you're going to, say, for example, convert a song to some kind of a representation that you can put in a data set, songs or people or currencies or whatever. But when you really think about it, the X's are coming from some process that a developer has done, which is to take the actual thing in the world, like I said, a song, and map it into some vector in some fixed dimensional space. A lot of the work in current machine learning is about doing stuff that doesn't involve fixed dimensional vector space. So we're not going to worry too much about that. We're going to actually get into just doing the programming piece to this soon. Now, we want to consider some possible solutions, and we're going to use the example of classifying the mail spam. Okay, so we want to look at this idea of a guess. Okay, or a fancy term for guess is a hypothesis. And we're going to guess about the relationship between X's and Y's. And so when we look at this email example, we say we've got an input, we've got our X, and we just don't know. This is an input of a email. And so we have this output relationship where it's either read, it's closed, it's spam, I don't want to read it, versus no, it's actually good email, I want to read it, it's not spam. And this is further defined by this idea of a +1 is a spam and a -1 is a good email that I want to read. And so we have this relationship here because we're trying to obtain a predictor function. And so we have our input of X and we're trying to have this predictor function and get a good solid output of Y. And if you look here with this particular framework, let's say we've got our data set, and you can see here the first one is an example of, that's not a good one. That has got to be spam. It's got a whole bunch of features on it that I don't like. And then the second one is, that's one I want to keep. It's for a course that I'm taking. And so we pass it through this learner function. And then here we are again looking at our predictor. It puts us into this idea where we want to do feature extraction. Okay, so we have these features about our emails that we want to extract. And so if I look at this from a task point of view, I want to predict my Y when a string X is an email address. Okay. And my question is, what properties of X might be relevant to predicting Y? And so we go through this exercise of feature extraction, and given an input of X, output set of a feature name or values, and we put that into a pair, right? This feature name value pair. And so if we look at this example, tom@gmail.com, and I go through this sort of process of extracting out some arbitrary features about the email that are really easy for me to identify. What I can do is look at some examples, and I can say, is the length longer than 10 characters? Is the fraction of alphanumeric characters to numbers 0.85? Does this email contain an @ symbol? Does it end with .com, and does it end with .org? And if you're looking at these numbers, you're saying, well, why are you selecting 1, 0.85, 1, 1, and 0? And it's kind of arbitrary at this point, right? And what we're saying is, for example, I know give it a 0 if it ends with .org, because that doesn't exist. Okay. But if it's got an @ symbol, then yes, give it a +1, because that's, it's an email. This is just arbitrary features that I'm extracting to do this. Okay. And so the numbers are relative to being meaningless, actually, but they're a starting point. As I continue on and I'm developing these features, we have these features, and I want to kind of repurpose the way I want to look at them. I want to put these features into a vector. Okay. And the next kind of evolution of this is I want to look at this idea of a weight vector. Okay. So what it's really saying is, for each feature J, have a real number, weight representing contribution of feature to predict. It's a lot more complicated when you read it in this format than it actually is in practice. And so we have this weight vector, and it's the same features, but now I want to reconsider the level of importance. It's like a test, right? How much is a test weighted versus an assignment versus a lab versus a quiz? Okay, so I want to re-examine these weight factors. And with these weight factors, I can again put those into a vector as well. And so if I look at this operation, a feature vector times a weight vector, what I produce is this score. Okay, and this score is the weighted combination of features. And so if we take this to one more level, and I've got my weight factors, and I've got my features that have been extracted, and I just add them, I can produce the score really easy. And, the sum total of this score is this 4.51. Okay, so that's just a numeric value that I'm getting with this score. And so if I take this a step further, what I'm saying is, if I have a score greater than 0, then give me a +1. If I have a score less than 0, then give me a -1. And if I have a score of 0, then it doesn't really matter. I don't care. Plus or minus, I don't really care. Okay, so this is really how we're dealing with a linear classifier. And really an important thing to show you with our linear classifier is probably to do it as a diagram. So I believe the best way to really show this is graphically. And so if we look at this weight vector, it's 2 and -1, and now I have this feature vector. And I plot this onto a graph. The first one I'm going to actually plot is my weight vector. And you can see there that it's 2 -1. It's the first one I'm plotting on my graph. And the origin always starts at 0, 0, which is where the tail is. And so once I plot that vector out from the origin, then I can go and plot the other points on here. And you'll notice that what I'm really interested in is the sign. Okay, I'm trying to get the sign of the product between the feature vector and the weight vector. And it's either plus, minus, or it's this kind of plus. For argument's sake, I'm just going to give it, because that final one actually resolves to 0. And so when it resolves to 0, like I said earlier, it could be plus or minus, but I'm just going to throw it out there as a sort of a plus, but not quite a minus. Not that it really matters. And what you see is the first point here I'm plotting, that's a plus. The second one is a minus, and then there's that third one. And, how do I distinguish between ultimately something being positive or minus when I have multiple samples, many, many samples? So this is the short version of a mathematical symbology of this. But I have this thing here, it's called a decision boundary, and it is perpendicular to my actual vector. Okay, it's a perfect right angle to my vector. And as you can see, anything on the right is a positive. Anything on the left becomes negative, except for that one at the top, which, because it's 0, I just threw it out there as, kind of a meaningless positive. And what happens is we've got this left side and right side, and you can see everything on the right is positive, everything on the left is negative. And this is really where we're trying to get to mathematically, programmatically, but this is what it looks like in two-dimensional space, because this is a 2D vector. And so we have this dash line, or this decision boundary. It's actually called a hyperplane. Okay, and because it's 2D, it's a dotted line, we'll say in this case. But if it was a 3D array with a third dimension, then we would have said that this was an actual plane instead of a line. Okay, so the hyperplane does become an actual three-dimensional plane. So if we are looking at this framework, and we have this learner in the middle between the training data and this prediction function, let's kind of look really, really briefly at this learner idea. And this learner idea in the middle is really broken down into two parts: the optimization problem and the optimization algorithm. And so what it really means is what to compute and how to compute it. Okay, and we're not going to spend too much time on this one because it's a much broader topic, but I want to talk really quickly about this idea of a loss function. And the loss function says this: a loss function which is X, Y, and W, quantifies how unhappy you would be if you used W to make a prediction on X when the correct output is Y. Okay, so really it's how happy are you if you're wrong? And what we want to do is get this number as close to 0 as possible. So it is a number we want to minimize as much as we possibly can. And so, we have to understand this thing, like how confident are we that we will get a score that is predicted to +1? Okay, what's our confidence level in that? And so when we do this, we have to calculate this thing called a margin. And by what margin or how correct are we? And the way to get the margin is just to take our score and then multiply it by our Y. Okay, take the score, multiply it by our output. And so when we have the margin that is less than or equal to 0, we know that we're actually making a mistake. Okay, and so let's kind of look at this 0, 1 loss. So 0 or 1, our loss returns either 0 or a 1. And if we try to graph this, what we're seeing is the margin on the bottom, which is our X, and then our loss, X, Y, and W. And really interesting the way this actually looks. If you see the blue line graphing on there, the margin is between, on the X-axis, in this case, -3 to +3. Okay, but the loss really is from 0 to 1. And so how we define being incorrect or correct is where we find ourselves on this particular graph. And so when we look at this idea of optimization, again, what to compute and how to compute it, how do we optimize? And the answer to that question is really we do this algorithm called gradient descent. And I am not going to actually get into the specifics of gradient descent. You could probably go to 3B, 1B to get a really great explanation of gradient descent. It's probably the best one out there. And I will include a link to that. But, understand how the mechanics of gradient descent actually works. So what I'd like to do now is actually get into some programming. And we're going to go into a Jupyter notebook and we're going to try an exercise of all of this. Okay, and I want to warn you, we've talked a lot about theoretical stuff in this video so far. But what we're going to do now is we're not going to pretend that we're PhDs in understanding all the science behind this. What we're going to do is realize that we're learning how to write software in Python to perform these different operations or these different predictions. And so what we're going to do is go get a sample size from the Kaggle website or Kaggle. And it's got about 3,000 different rows in this, or samples of emails. And we're going to try and make a prediction based on the input. And we're going to try to output our spam. So spam is going to be a +1. And if it is a valid email, it'll have a value of 0. Okay, and so what we're not going to see is all the fancy stuff behind the curtain. Okay, what we're going to do is implement the tools as Python and other developers have created for us, and we're going to implement that. So let's go over to our Jupyter notebook and start really looking at how to do or perform this whole operation. There are a couple things I want to show you here now that I've got this Jupyter notebook open. And I've just titled this one Working with NumPy. I want to show you a couple of subtle differences here. Okay, in this section here, I have A and B. Okay, I've got these two arrays, A and B. Now, if I want to add them together, and I just do it without any imports of anything else, just standalone, I'm doing A plus B, and I'm assigning it to C. And now if I just run this, you see what's happening is it's really just, in a sense, concatenating the two arrays together. But when I do it in this fashion with NumPy, and I import my NP or NumPy, and then I try to perform this same operation. You can see here it's just a plus b again, and it's the same two arrays. And what'll happen is the difference is it's pretty significant the way it's outputting this, because it's not really performing the same idea as concatenation. And here what's happening is when I run this, now I'm actually adding the two columns. So you can see that the two arrays are stacked into rows and columns. And you can see that it's just performing that simple addition to the two. Okay, so here what we're saying is concatenate them all into one line, but here what I'm saying is no, take each and add each index to one another. And so that's what you're seeing as a result. Now there's this other idea that I want to talk about. It's this dot product, right? And it's something that you're going to hear quite often, and we're dealing with a couple of matrices. And again, I'm using A and B. And what I'm saying here is this is how I would do a dot product by hand, like literally with no help. This is the raw method of coding it. And so if I undo this and I go ahead and I print this, what you're seeing is I'm talking about A, and I'm doing it by the element. Okay, and you can see 0, then 1, then 2, then 3, and that's because my array has sort of 4 indexes in it. And so when I run this one, I get a result of 13. Okay, but there is a simpler way to do this using NumPy. Okay, and that is actually to call the dot product. So this is a function or method within Python called really the dot product. And if you want to use it, you simply are getting, this little line of code here is performing all of this. Okay, so this function is coded by NumPy to do all that operation for you. So you can see here, if I just uncomment that and then I run it, I get the same exact output. Okay, and you might be asking, well, why did you switch them from B to A? And the answer is that in this particular example, it doesn't really matter, right? If I were to switch this to A and B, it doesn't matter. I can run that. I get the same output. But the reason I'm switching them is you'll see later on when you get into doing a neural network, when we are multiplying our inputs versus our weights, it will actually make a difference. So, typically what I would say is just for now, just do it backwards so you're comfortable with it. Okay. But again, it produces the same exact output. So what I want to do now though, is I want to start a new notebook, and it'll be in Python 3. And I think I'm just going to call this one spam detector. That's all I'm going to do. Okay. And you can see if I shut this one off, you can go into here and you'll see I now have spam detector as my project file. And there it is. Okay. And the other thing is I've already gone to Kaggle, and I've downloaded this spam or not spam CSV. So I already have that, but let me show you where to get that. So when you go into Kaggle and you go to data, you can type in right down here, and I just started off, the first word I typed in was spam, but I got this spam or not spam data set, this one here. And you can see it, there's the name of it down there, and then you can download it. And of course, I've already downloaded it, and it will look like spam or not spam.csv. Okay, so I have that already in my file, and it's in the same file that I'm using for this new spam detector. Okay, so it's on the same level. So let's go back to this and get started. Let me shut that down. So let's start off with just a quick comment. Okay, This program detects if mail is spam or not spam. To be or not to be spam. Okay, and if it is spam, what I'm going to do is give it a value of 1. Okay, I may adjust that later, but probably not. But let's see what happens. And this will have a value of 0. Okay. So I'm just going to leave that as the comment above, and change the editing there. And I'm going to do B. I'll just type in B for below. You can see it's blue, so I'm going to B for below. And here I'm going to say libraries. So that's all my libraries. And so the first one is going to be NumPy as NP. Second one is going to be import pandas as PD. Okay, and the next one, this one is from the natural language processing kit. Natural language kit, basically. And it's an important one, NLTK. And then so from NLTK.corpus import stop words. Okay, import stop words, and then finally import string. Okay, and so let me just check and see if everything is okay. And I've got something wrong right off the bat. So I probably spelled pandas wrong. And I did. Okay, so I'm good. So in my next cell, what I'm going to do is go and get the CSV file that I had. So this is just DF, similar to what we did last time, which will be PD read underscore CSV. Okay, and in that is just single quotes of what I'd prefer to actually do is to go to here. Oops. What I prefer to do is to go here, highlight it, and then just copy it. So Control C, go into here, and then paste it in there. That way there's no doubt that I'm spelling it perfect. Okay. So now that I have my data frame, I want to go and have a look at it. So I'm just going to type in data frame and then run this. And you can see a couple of things here. We've got sort of three columns to this. The number, or let's say serial if this was on a spreadsheet, the email itself, and then it's got this label on there. Okay, so I don't want to see that much of it. So if I say I want my data frame just to show me the head, what I can do is just say, just show me the first 5. Okay, and you'll see here I've got these labels that are 0 and 1, right? And so when I run this, my labels change, but that's only because I'm outputting the top 5. Okay, so I want to learn a little more about my actual CSV file, and I need to know the shape of it, and that's we just refer to data file dot shape. Okay, and that's all. And when I run this, you can see I have about 3,000 records or 3,000 emails to choose from, and there's 2 columns really. So this is a reflection of rows and columns. So even here, maybe I can just type in a comment that says the shape is reflecting rows first and columns. And you can see there's 2 columns. Okay, so really it's email and label. So I want to get my, let's do this, get column names. And this is just as easy as the other one. Okay, so I go to my data frame and I just type in column with an S. Okay, and if I run this, you can see that I'm getting email and label, which we already knew just by looking up here. So that's no surprise to anybody what we've got. But I want to make sure that I don't have any surprises. So it's good to know the columns that I have. And in this one, it's a simple exercise. So really, you have to understand, you know, with the shape, when it gave us the shape, there was only, you know, 2. Had there been several different columns, this would have become more important to us. So now I've got 3,000 records, 3,000 rows, and I want to see if I have duplicates. So let's say check duplicate and then get rid of them. So I only want one version of and remove if found. And again, this is, you know, my data frame dot drop underscore duplicate with an S because it's pluralized. And then we're saying in place and underscore, or not underscore, equals to true, and make sure it's capital T. Okay, and that's all. And let's run that. Sorry, I need to actually hang on. And so again, all I want is this data frame shape again to run that. Okay, and so you see that there was, it looks to me like, you know, 100 and almost 130-ish records were duplicates and that they've been dropped. So we've gone from 3,000 down to 2,873. So next thing I want to do is I do want to have a sort of overall quick look at the data itself. And I'm looking for nulls. And so I'll put in a comment here, show any, so it would be NaN, it would be N, lowercase n, capital N, or Na. Okay, and you know, the way I'm going to do this is with my data frame, and it's simple, is null. And this is all lowercase, is null. And then I want a sum of that, dot sum. And of course, that's a method call as well. Okay. And let's go ahead and run that. Okay. And so you're seeing that I do have one email that fits that condition. That's not bad out of, you know, 3,000. Okay. So moving on, the next thing I want to do is get something called stop words. A stop words package. Okay, and to do that, it's just going to be nltk dot download. Make sure you spell it right. I have a hard time with that sometimes. And it's just in brackets, stop word. Okay, and then just run that. And it helps if you spell things correctly. Stop words with an S. So run this. And you can see it's downloading this. Okay. Which is good. And it returns a value of true. So I've got stop words in here. Next thing I want to do is actually, I want to do a function that will allow me to process the text. And we'll do, we're just going to call it process underscore text, and I'll pass it one parameter, text. And with this, you know, let me put a comment up here what we're going to do with this. And there's 3 pieces we'll do. We're going to remove punctuation, and then stop words. And stop words are just useless text that have really no meaning to the text at all. It's just garbage in there, okay? And then we're going to return a list of clean text, text words. Okay, that's what we're going to do with this. So let's go look at the first line, and I'm going to say no punc. So no punctuation. Okay, this is a variable that I'm creating. And normally when I code, I like to do the right-hand side and then assign it to something, but I'm just gonna choose to do it this way. And I need a char. Okay, so this is really a just a for. Okay, so just follow along with the text and we'll talk about it after. So char for in text. Now, if our character is not in string dot punctuation. Okay, so that's all that line of code is. So it's just saying if the character in the text, or sorry, that's not right. That shouldn't be an in. So for text, wow, I don't know what happened there, but I made a mess of that line. So this should be for, not, that should be char in text if char is not in the string punctuation. Okay, so I'm trying to clean up the punctuation ultimately with this line of code. Okay, and then no punc is going to be, I'm going to join it. So I've got this empty string here, and I'm going to call the join function here, and I'm going to pass it no punc. Okay, so that's kind of all I'm doing on that first little piece. Now I still need to clean it. So I want to clean my words, and let me do it the right way. So I'll do the logic and then I'll assign it to something. So if I say word for words, word for word in punc, no punc, sorry, no punc dot split if word dot lower not in stop words. And that's actually a method, and I need to tell it to set it to English. Okay, so I didn't assign this to anything yet. And so I'm going to equal this and assign it to clean words. Okay. So truly we haven't really done anything yet. Okay, we've just imported some packages, we've done some importing, we've cleaned up, or we're just attempting to clean up the data a little bit. We've defined what the shape of this thing is. We actually haven't done anything yet. We're just dealing with the data that we have. So, you know, almost done, but not quite. We need to return the result of all this work. So return clean underscore words. There. So if I run this, you see right away, I've got an error, and it's a painfully obvious one. When I did the definition of the function, what I didn't put in was my colon at the end. And so if I run this again, let's see if I get another error. So it looks to me like my indenting it's not appropriate. And I can probably just tab everything over manually and then try and run that and return. Okay, so this is the process text method or function. So there's one little issue I do think I have to fix. So this stop words should be a dot words. Okay, that's something I didn't call. I'm probably going to get an error from that. And so next thing I want to do is do something called tokenization. And really, I'm just going to try and show you stuff separated by commas. Okay, so again, your data frame dot, or not dot, sorry, square brackets, and we want to, it's email that we're after. Okay, so I want to look at this email right here. This is what I'm after. So you can see in the index, these are our column headings. I'm interested in the email. And so if I go to here and I go to email, and I just want to see, let's say the head, right? It's dot head, and then with the brackets, and then apply. And then I'm going to apply the method that we just called, or the function. So this process text right here, this is what I want to apply. Okay, put that in there. All right. And let's run this and see if I have any errors. Okay, so I do have an error right off the bat. So I made a number of errors that I just was not paying attention to. I was sort of focused on the text itself. And the errors I made is where I was referring to text. So for example, the first time when I wrote this, I had text. Okay, this shouldn't have been text. It should have actually been email. Because what I'm trying to get is, you know, this here, my labels in my columns. Okay, so this should be email here. Okay, and then when I go to this this line here, this was text. This should be email as well. And so finally, when I want to go and look at this and get those tokens, this should be email again. Okay, so make sure you kind of look at your code if you're following along and change this to email, not to text. Okay, let me put a comment in here as well. And my comment is going to be to display token tokenization. And you can see here what's going on. And I've got each of the columns here, or each of the words inside that email are separated by a comma. Okay, and that's really just tokenization. That's what I was trying to do. Separate out each individual word by a comma. So one thing I do want to do is I'd like to show you what's going on here. Let's take our very first email. The first word is date, Wednesday, number. So if we actually open that up, you can see this is the email itself. Date, wed, number, og, number. Okay, so this is what we're seeing here. And there's 3 dots just to say, hey, there's a lot more text here, but you just don't need to see it. Okay, so if you look at all the garbage that's in there, right? This is what we're trying to separate. So let me close that. Next thing I'm going to do is I want to explain some stuff. So, okay, hopefully I typed explanation. And this is not necessarily applicable to the code that we've been writing. This is an explanation, and then I'll probably pull some code out of this after. So you don't have to do it, but you just have to understand what's going on. So if I say I've got message, let's say 1, and I'm gonna make this say hi. Let's do hello world. It's classic. Hello. Hello world. Hi. Hello world. Good day. Good day. I'll do that as one word. Doesn't matter. Okay, so that's my first message. Then I'm going to say message 2 is going to say something like test. I don't know. Hi, Tom. How about that? I don't know. I'm just making it up to try to explain it. Okay, not hi. Good morning. and I'll do it all as one word for good morning. Okay, so that's what I've got there. Now I'm going to say print off my first message, and that's just going to be message 1. Okay, and then I can print that off. All right, and if we look and see what happens with that, you can see that it prints off the line. Okay, and I don't really need to worry about that right now. But now the next thing I do want to do though is I want to convert the text to a matrix of tokens. Okay, so I want to convert this into a matrix, all this stuff here in this box. And the way I'm going to do this is going to be from sklearn. Okay, so it's from sklearn dot feature underscore extraction, feature extraction dot text. Okay, and then import counter or count vectorizer, COUNT, count, capital vector IZER. Okay, and hopefully I spelled that right. Okay, so now I'm going to do this, we're going to call it bag of words. Okay, so instead of typing out bag of words, I'll say BOW, just BOW, bag of words. And that's going to be counter. Okay, I'm going to just do this. It's safer in terms of spelling. Counter vectorizer, and that's a method call. So we're going to do fit underscore transform. Okay, and in here, I want to do a list of lists. Okay, so I'll put my round brackets, and in here it'll be my list of lists. So here, and then this next one is, sorry, I know it's painful to watch me type, I get that. We're gonna say mess 1. Okay, and then in the other one we'll do a comma, brackets, and then we'll say mess 2. And so I'm not done with this count vectorizer. What I want to do is give it this thing called an analyzer. Okay, and it's analyzer, and we're going to set that analyzer to the function that we created. Okay, so that should be good there. And now I want to just print my BOW. So print. Okay, let's see how this looks. All right, so what are we seeing here? If we look at message 1 and message 2, we see a couple of different things. Okay, we're seeing hello world, hi, hello, good day. Okay, so first, message 1, okay, is represented by the 0. Okay, that's how we know this is the first message. And then of course message 2 is represented by these 1s. And so you can see that I have these 4 rows, and it means that I have really 4 unique words in message 1. So hello is unique. It's an individual word, but you can see there's 2 of them. Okay, and then hello is another one, and again you can see there's an or world is one. There's another one. Okay, and then there's hi, which is 1, and then good day. Okay, so that's why I'm printing out 4 of these here. Okay, and then if you look at the next one, test, test, test. Okay, there's one. The test is one single word, but it appears 3 times. And then you've got good morning, and then you have Tom. And that's why really in message 2, there are only 3 unique words in that whole sentence. And that's why you're getting 3 rows like this. Okay. And so here we're saying we have two words that are the same here, hello and hello. Okay, and then again you have world and world. And then there's one hi and there's one good day. Same thing here. There's 3 tests, one good morning and one Tom. So I want to actually now, I want to print out the shape of this. So it's going to be print and then just bow dot shape. Okay. And let me look at what the shape of this is now. So you can see that it's 2, 7. And so what that means is I've got 2 rows because I only have 2 messages, but I have 7 columns. And what the 7 columns is doing is it's comparing, it's looking through and it's looking for all of the unique words. Okay, so hello, world, hi, good day, test, good morning, and Tom. Okay, so it's looking for those 7 words. Okay, so that's just really an explanation, but it's not entirely part of what we're doing here. Okay, so I'll probably end up commenting it out, but I will take some pieces from here. So now what I'm going to do is just continue on. And I'm going to borrow some of this, obviously. Okay, so what I think I want to do is I'm going to take this because I don't really feel like I should retype the whole entire thing. So I'll copy that. And I'm going to do some editing here. Okay, and this is going to be, I'm going to change this. So messages, bag of words. Okay, and this isn't going to be defined like this. I will get rid of this. Don't need the extra bracket, I don't think. Okay, and inside here, this is going to be, I'm going to change this to emails. Let me make sure. Yeah, it's just single email. Change that to email. And I'm basically using all of the same things here. Okay, and I'm wondering, do I really need to? Yeah, okay. So I'll keep in this line, this sklearn, the feature extractor. Okay, I'm gonna leave that in there. So if all goes well, I should be able to run this, and hopefully it'll go okay. Actually, the one thing I do need to do in this transform is df that. Okay, so my data frame has to be part of that part there. So I'm just kind of looking at the shape here, just to sort of show you guys something if you didn't know. You see this star that is inside the brackets. It means that your kernel is busy processing something. Okay, that's all that's really doing. And eventually when it's done processing that will cease. And you'll see, I think this dot will turn to a different color, but you can see it says that the kernel is busy. Okay, so when it's done its thing, it'll change color and you'll be fine. I think the next thing I want to do is actually split the data into 80% test or training and 20% testing. Okay, and we've sort of done something like this before. So from sklearn dot model underscore selection import train underscore test underscore split train test split. Okay, and then we've got these 4 that we want. So x underscore train, and then x again, test, and then lowercase y underscore train, and again, lowercase underscore test. Okay, so I've got 2 train and 2 tests. Okay, and this, I'm going to set this to train underscore test underscore split. And inside here will be our message or messages underscore BOW. Well, I'm not done with that one yet. I have more parameters to put in there. So we're going to df, and inside here, I'm actually going to refer to the label. Okay, so if you remember on our, when we imported this, the 2 column headings are email and label. Okay, so let's go outside of that. And I'm going to say test underscore size is going to be equal to 0.20, comma. And then finally, I have this thing, this random underscore state, and I'm going to set this to 0. Okay. Okay, next thing I do want to do is change this to B for below. And I want to look at the shape of this. Get the shape. Okay. And that's just messages, bag of words, dot shape. That's all that should be. And hopefully this is actually going to run, and because I haven't tested it in a little bit. So let's run that. Okay. So let's back up a little bit, because I was getting this error. Okay. And really what it's coming down to is this line of code here. Okay. I was trying to run this and my kernel was processing for a long time. And unfortunately, it forced me to go on to Snob Overflow, and I hate doing that. Okay, so I put in this comment into Snob Overflow, and it had some suggestions. Okay, and use Snob Overflow at your own risk. Okay, that's all I'm going to say. But it looks like I need to go and grab this value, because when I went to test it, like initially I didn't have any errors, but when I went to actually test this shape, I got a 1 and 1, and I knew that instinctively was just wrong. So what I'm going to do is I'm going to add this line right after. So this dot values dot as type u. And what it's referring to is this Unicode string. Okay, so I'm going to play around with this and I'll make sure that it works. But it takes a long time to process this, so I'll pause the video and then give you an update. So while I've done the update, if you're new to programming and you happen to go on to Stack Overflow, and I refer to it as Snob Overflow because some of these people can be really quite abrasive, snobby. And this is my favorite thing I want to share in this video by this person here. And I love this comment because somebody said, the term as clearly mentioned. So he writes, as is clearly mentioned in the back, the traceback is an unhelpful slight to the person asking the question. So I wanted to share that because if you ever go on Snob Overflow and try to help someone out, keep in mind they're asking for help. So don't berate them for doing so. And I love the fact that this person pushed back. That was pretty good. Let's go back and see what's happening. Okay, it's still processing that. And one thing I had to do was balance out my brackets. Okay, after the email, I had a bracket. So make sure if you're doing this, you balance out the brackets. And you can see that the kernel is still busy. Okay, so the kernel finished. That's good. Now what I want to do is try to run this. Perfect. Okay, so that did solve our problem. Was this type, this value type. Okay, so now it's really, I'm quite happy with what's going on now that I can see the shape of this. Okay, so if you update your code to do this, make sure that you balance out your brackets properly. Okay, let's continue. Okay, so this is broken down into rows and columns. Okay, so I want to go back up 2873. Yeah, and so after we did that drop duplicate, we're still in the same number of records, 2873, but now you see we have all these columns. So something we haven't talked about before is this naive Bayes classifier. Okay, and so we're going to use this particular model to make the prediction. All right, and there's a lot of stuff on YouTube, I'm sure, about naive Bayes. There's tons of it. So, you know, that's something you may want to get familiar with as well. So I'm just going to, I'll do a comment, create and train the naive Bayes. So it's naive Bayes. I believe he's a mathematician. Classifier. Okay, so let's keep going with that. Okay, so I've got that here, and I'm going to code and then we're going to talk. So from sklearn again dot naive naive underscore Bayes, naive Bayes, import its multinomial NB, capital NB, multinomial naive Bayes. Okay, and we're gonna use this like this. So we're gonna say multinomial naive Bayes. Multinomial. It looks like I spelled it right. We'll find out if we get an error. Multinomial naive Bayes. And this is a function, right? And we're going to do a fit. So within our fit, not fit, sorry. We're going to get the training data. So it's going to be x underscore train. X underscore train and y, lowercase y underscore train. Okay. And when I get that, now I want to put that into a classifier. So this is going to equal to classifier. Okay. This is how I'm going to get the classifier. All into, I perform this operation and then assign it to my classifier variable. And let's see what happens when I run it. Okay, I'm getting an error. Okay, so xtrain is not defined. Let's clean that up. So a bit of a challenge I had is it wasn't picking up my xtrain or my ytrain, right? I was getting that error. So sometimes with this, it seems like you have to go into it. I had to run this cell. Run the next one, and then I could go in there, run it again, and then it would pick it up. Okay, so it wasn't actually looking back and seeing this xtrain right here. Okay, so let's keep going. Well, let's go down to the next thing, and we're gonna do this print predictions. Okay, and with print my predictions, it's just going to be print, and inside here is the classifier dot predict. And what am I trying to predict? I'm going to just try right now to predict my X train. So capital X underscore train. AIN. Okay. And let's have a, before I do that, I want to do one more thing. I'll go to the next line. I'm going to say, print the actual values. And what this is going to be is just print, again, call my print function, y underscore train. Okay, and then let's have a look at this. Let's see if this runs. Okay, so we have some different things going on here. And first off, I'm happy that it works. So I want to block that out and then rerun this. And so what am I getting here? I'm getting this prediction, right? But there's so many rows here. And, you know, this is the first three. This is everything in the middle. And then this is the predictions of the last three out of 2,873. Okay, so when we look at this here, in fact, let me just make one other change. I'm going to type in dot values. So dot values. Okay, and I'm going to run this now. Okay, it's interesting at the moment that it's actually you know, matching up really well. But let me take that out for one more second, X, and I'll run this. Okay, so you're getting this prediction, but this is in the middle is the actual values. Okay, and so you're seeing the first three, 1, 0, 0, and then the last three is 0, 1, 1. So that's really what you're getting a view of right now. So, which is why I've got the values in there. So if I run that again, it's really the same sort of thing. So what I need to do is look at this and say, you know, how good was my evaluation? How good did the model evaluate the training data set? All right, so let's do a comment in here. Okay, and we'll say evaluate the model. On training. Okay, so what is this going to look like? I'm going to go and use some of these imports from sklearn. So again, it'll be from sklearn. Okay, so sklearn, and I'm going to call this thing called metrics. Metrics and import. This is a long one. Classification underscore report. Okay, and I've got classification report. Then I want to do something called a confusion matrix. Confusion, I'm the only one confused with my spelling. Confusion underscore matrix. And accuracy. Accuracy underscore 4. Okay, so hopefully I've spelled those right. And I'll make this, I have to use this classification classifier. Classifier dot predict. Classifier dot predict, and I'm going to use it on the capital X train. And now that I kind of know what I want to do, I will assign that to a variable called pred. Okay, that's all I'll do with this. So I've got pred. And let's go down to the next line. And we're going to print this. So print, and inside my print is going to be my classification report. Okay, so copy that. I'll print that off. And then in here, it's going to be on my lowercase y train. Okay, and then pred. Okay, and let's have a quick look and see if we've made any mistakes. So if I run that, okay, good. So let's have a look at what we're seeing here. Okay, so far so good. Let's do a little bit more. I'm going to print. I'm just going to add in. Do I want to print another line? I'm just going to put that in there as a spacer. So if I do print, and inside here, we're going to call this confusion. I never in my life entered a spelling bee. I cannot talk and type at the same time. I can barely type. So confusion matrix, okay, with a colon and a space, and I'm going to do a \n And I think that comes from the C programming language originally. So I'll put a comma in there, and we're going to call this the confusion matrix. Okay, and it will take two arguments. So we're going to do lowercase y train, and then again our predict. So PRED. Okay, and let me just tighten that up, and let me really run this. Okay, so we've got the confusion matrix, and we'll come back to it on what all this means. Okay. So the next thing I do want to do is this. I'll just take all this, copy it, go right below that, and then instead of confusion matrix, I'm going to say accuracy. Accuracy. Okay, and then I don't want the confusion matrix. What I want is my accuracy score. Okay. But everything else will stay the same. So I'm going to call that method. Let's run this. Okay, so my accuracy. This is my accuracy now. Okay, so ultimately what this is coming down to is the fact that we are accurately predicting our spam on all of the testing, the training data. And we've been able to actually predict it to an accuracy of 99.65% this time around, okay? If we run that again, the number doesn't change, right? So our accuracy prediction is 99.65. So I think that's pretty good on the training, okay? And you can go through and kind of figure out what these other ones mean, but really ultimately we're doing pretty great here. Okay. So next thing I'm going to do is I'm going to go up and grab this code here, this print predictions. And I go to the new cell, and now I want to do this with the testing, right? So my X test, and right here, okay, and yeah, and I'm just going to make sure that it runs. Wow, lots of data in there, right? So I'm going to go up to here and take this whole evaluation, take that whole thing here, copy that, come back to the next cell, and make some edits in here as well. So I've got this one here, and I'm going to change this to test. Okay, and then this one will be test. Oh, so this is test, and I can just copy and paste these parameters. Put that in there, and here. And so let's go and have a look at this. Okay, so a couple of things right off the bat when I look at this. Our accuracy has actually dropped a little bit. Okay, because up here you can see, let me hide that print, rerun that. That's interesting. Sorry, I just forgot to comment out the other one. I'm just going to hide that. But if you notice on our training set, we're at 99.65, but down here we actually drop to 98, which is still pretty phenomenal, but we drop a little bit. So just to kind of go back a little bit and recap, I am going to talk about the other things right now, but I'm going to just not really spend time on that confusion matrix at the moment. And I think I'll comment those out, because I'm not really prepared to talk about those right now. So if we run those, we can kind of just blank them out. Now, the important thing is the accuracy of the predictions that we've made, right? And something that I want you to understand is that, for a number of years now, many developers have gone in and created all of these background Python tools. Okay, so I want to use the analogy of literally a toolbox full of tools. Okay, you might go into your toolbox and find a hammer. Okay, but you don't make the hammer normally. I mean, some people can, but you didn't manufacture the hammer, but you went into the toolbox and you used the hammer to accomplish some sort of a task. Okay, so software is a little bit in the same way. that there's many people out there that are producing all of these different tools in the toolbox. And this is an example of how we get to benefit from all of that work. So it's one thing to understand the background theory of what is going on, but what you're not actually seeing is all of the code that goes into some of these things. I mean, you can access those. You can definitely get into sklearn, read all the documentation, figure out what's going on in the background. Um, but ultimately, if you're a scientist, you want to know in intimate detail all of that theoretical stuff so that you can build bigger and better things in the world of AI. But if you're a practitioner or you're writing machine learning projects, you have to understand the tools of the trade. So you have to understand what are the tools available to you in the toolbox. Okay, so I've explained sort of theoretical stuff, and now we've gone to a very simplified application between spam and no spam. Okay, so what you're not seeing is the thousands of hours of scientific research and development that have gone into all of these function calls like this one here, like this predict. Okay, and the fact that we're using sklearn and all of these different items right here from sklearn. Okay, so I hope that you kind of understand that you need to strike a balance between knowing all of the theory and actually using it. You didn't build your car necessarily, but you have to know how to use it. What are the tools available to drive your car? So I've covered a lot of the tools of the trade, what's going on in here, but ultimately at the end of the day, we're just trying to predict a spam or not spam based on a bunch of samples. Okay, so anyway, I'm going to end the video there, and I will see you next time. Thanks.